Hello everyone. We are going to learn today how to solve logarithmic equations. So I'm going to start with recalling some properties. So the first one is called the power rule. So when you have total sum of logarithmic expressions, we can write it as a single logarithm as a product of linear values. And if you have a difference of two logarithmic expressions, we can write it as a quotient of inner values. And also, if the logarithm is multiplied by a constant k, you can take it inside to the logarithm, making it to the power of the inside value. Okay, when solving equations, we will need these two properties too. When you have a logarithm expression log to the base a of b equals c, we can convert into an exponential form. So get rid of this log term. What we do, we take this base, we take to the other side and raise it to this power. Then we have b equal a to the power c. So that is the exponential form. And also, if you have two logarithm terms with the same base equal to each other, so we can just get rid of these log terms and then we have x equal y. So these expressions we are going to use when we are doing our computations and simplifications here. Okay, so and also note that these properties can be used to write if you have logarithmic expression involving more than one log term, so you can compress it and get it like a single log term. Okay, so let's try to solve logarithmic equations. Solving logarithmic equations. So I'm going to do this first example, which is an easier one. 2x plus 5 equal to 3. Okay, look at this problem. So you can see this form is similar to this one, right? Our aim is to get rid of this logarithm because my variable is inside this. So I have to get rid of this log term and convert it into a usual type of equation. So I can take this base and raise it to this power. So I will get 2x plus 5 equal to 2 cube. Now you can see this is a very simple equation, so we can solve it for x. So we have 2x equal 8 minus 5, x equal 3 over 5. So that is my answer. But before accepting this answer, there's very important thing you have to do, because I have to check whether this is an acceptable answer. What do I mean by that? So you know, if you remember the logarithmic function, the graph. So this graph is defined, or the log function is defined only for x greater than 0. So whenever you have a negative value inside the log term, it cannot be defined. So you have to make sure this value you get here, when you check this with the original expression, it will give you a defined value, or otherwise it's not undefined. Okay, now you can see this value do not have any problem with this one. It will keep this positive. So this is an acceptable answer. Let's do another example. So of a different type, log to the base 7 of 2x plus log to the base 7 of 18. Right. see, we have so many terms involving here, but we have everything involving log. So it seems like we can convert this into this form of simplified version. Okay, before that, we may need to use our first property here to combine this into a single logarithmic term. Okay, how can we do that? We have a summation here, so we can convert it to a product. So we will get log to the base 7, 2x times x is 2x squared, and here you have log to the base 7, 80. Now we have this form, right? What we can do, we can get rid of this logarithm, and inside function will be equal. So we have 2x squared equal 80. And again, a simple equation of x, so we can solve it. X squared will be 9, x will be 3, or x will be negative 3. Now back to that important step, we have to check our answers. What about x equal 3? Check with the original problem. So this is positive, so no problem here. This is positive, no problem here. So this is an acceptable answer. Okay. What about negative 3? So when you apply here, you can see this is negative 6. So it's going to make this undefined. So this is not an acceptable answer. Right. So this is of this form. So we will do another example, so to make understandable. Okay. All right. This one, 2x. Now we have a difference, x plus 3 equal to. Okay. Now you can see this side we involving log terms. Here we have a constant. Seems like we can convert it into this form, and we can solve it in this way. Okay. First we have to make it to a single logarithmic term. So you have a difference, so we can convert it into a quotient. Okay. Log to the base 5, 2x over x plus 3 equal to. Right. Now we are going to use this and convert it into an exponential form. We have 5, take it to the other side, press it to this power. So what we will get? I will continue here. We have 2x over x plus 3 equal 5 squared. So now we can see we have a very simple expression of x, no more log terms, so we can solve it. Alright, let's see what we will get. 25 times x plus 3, 2x, 25x, 75, negative 23x, 75, x equal negative 75 over 23. Right, so this is the answer we got. Still we have to check. What can you say about this answer? If you plug it here, it will make these log terms negative. So that means this is not an acceptable answer. So this cannot be accepted. So for this equation, we have no solutions. Okay, I hope you understand how to solve a logarithmic equation. Thank you.